Practitioners kind of vary on that, but I tend to err on the side of using the 10-year rates. But at this point, it's all theoretical. Okay. So CAPM model says that these investors will prefer portfolios or assets with higher reward to risk ratio, which is defined as excess return divided by the beta of that fund. Okay. I think this is known as the Trainer ratio, if I'm not mistaken, or Sharpe ratio. I don't know. Look it up. Well, if that is the case, assets with higher reward to risk ratios are going to be in demand, right? If an asset is more on demand, price of that is going to go up. But if the price now goes up, expected return is going to come down. So market forces will make sure that all portfolios have exactly the same expected reward and risk ratios. Remember, these are models. Models, by their very nature, are approximations to reality, especially in even in physical sciences, they are approximation to reality. When Newton came up with his theory of gravitation, he has three laws of motion. They were approximations. It worked very well when you were trying to predict the orbit of Jupiter, but it didn't work that well when you were trying to predict the orbit of Mercury. And in fact, that was kind of the puzzle that ended up essentially giving birth to general relativity. Einstein's theory said, okay, right here, my theory predicts exactly where Mercury's orbit is going to be. Even general relativity is an approximation. Very close to black hole, which is an extreme source of gravity. It is so extreme, even the light cannot escape. It has nothing to do with gravitation. In general relativity, gravity is the result of the curvature of the space-time. Think of space-time as an infinitely elastic piece of fabric, and you drop sun in the middle of it. It's major mass. If you drop the bowling ball into a fabric like that, it's going to create a dent around it, right? But that's going to create curvature, which is going to exert force on some other object on the other end. It's going to pull it because of the slope. Now, a black hole, that slope is so big, so steep, every source of gravity has an equivalent escape velocity. If you wanted to send an object outside of Earth orbit, it has to travel at a speed faster than 9.8 meters per second, which is the so-called Newton's constant. Okay? If you cannot maintain that speed, you're going to fall back to the Earth. But in black hole, that escape velocity is higher than speed of light. So light is trying to get out, but it is not fast enough, so it cannot go out. Or alternatively, that slope is so steep, light has no way of getting out. Around that, even Einstein's laws of gravity don't work. You're in the quantum mode. And the quantum stuff predicts what's going to happen in very tiny environments very well, but it cannot do anything about microscopic stuff. So they're all approximations to reality, and all models are useful as long as you use them in a context where they should be useful. So in this case, this is the first capital asset pricing model. In fact, it brought Harry Markowitz's Nobel Prize in economics. That was also his PhD dissertation in Harvard. Man, things were so easy those days. We always say that. I mean, I'm sure, Einstein didn't think the stuff that he has done was easy. In fact, it took him 10 years to go from special relativity to general relativity, not because he didn't know what his model was going to be like. He knew what his model was going to be like. It took him 10 years to learn the mathematics to handle general relativity, because it was mathematics over non-Euclidean spaces. The geometry is very different. If that is the case, for any two portfolios, J is not equal to K, okay? You have to have RJT, RFT, for all JK. J is not equal to K. All right? That's reverse A means for all. Well, if that is the case, this also applies to the market portfolio, right? Pick market portfolio for K. Remember, in that case, RKT is going to be the return on the market portfolio, and beta K is going to be exactly equal to 1. That means for any portfolio, or rearrange return on the portfolio is going to be risk-free rate plus and we actually have a special name for that. We call this, come on. So to what extent market is overall rewarding you with a return over and above the risk-free rate? If we took the market portfolio as the entire stock market, historically, the last 120 years or so, that number is about 8%. Okay, but the entire market is a lot riskier than a treasury bill, so that's kind of your reward. If you look at the last 40 years or so, that number is closer to 6 a little bit, because the nature of the market in 1870s is very different from the nature of the market now. It was not that easy to short stuff those days. These days you can. Options markets didn't exist before 1974. I mean, there was options market, but nobody knew how to actually price them. And after the Black and Scholes paper in 1973, we had a systematic way of thinking about it. So the nature of the market is very different. It basically says the differences between, you can think of these as expected rewards, okay? Expected return on a portfolio is risk-free rate plus to what extent you're exposed to systematic risk times how much the market is being rewarded for taking the risk. Sounds like rather simple, right? We're going to talk about how to actually estimate those betas, but for now, very simple. For example, let's take RFP to be 10-year T-bond yield, which is about 4.2% these days. And let's take market risk premium, about 6%. For example, for Coke, and we'll talk about whether or not that's a good estimate, but by the way, today was also a historic day. Japan was the last country that had a negative short-term interest rate. They no longer have that. They were all the way down in negative terms, all the way to negative 0.1. As of today, it's 0.0 to 0.1. That's their target range. That's actually celebrated in Japan. They've been there almost 20 years.